Alright, so this is inclined plane, wedges, and screws. This is probably slightly more difficult than the first section. The hard part is the screws, which I just kind of crossed off. But a good portion of this will be reviews, so this shouldn't take very long. Right, so you've got inclined plane is like a roller coaster going up the ramp. Wedge is like an axe that's going to split like a piece of wood or something like that apart. And a screw is something that you turn and then turns into linear motion. That kind of makes sense. Review of mechanical advantage. It's the ratio to the magnitude of the resistance and effort forces and the resistance and effort distances. And you can use that to calculate or to manipulate speed, distance, force, and function. These were all the last. The one unfortunate thing about me doing this with your class is the animations don't work on this program I use to record it, so you don't get to see the cool boxes lifting up and going up the ramp. Oh. Alright. So if you have a mechanical advantage of 4 to 1, what that tells us is the force to lift it is 4 times less than the magnitude of the resistance force, and the distance traveled, though, is 4 times greater. 1 is still like the magic number for mechanical advantage. If it's greater than 1, less force is required, but a greater distance is required. Less than 1, greater force, less distance. Make sense? Alright, IMA, it's still effort distance over resistance distance. Remember, we can also write this as ideal resistance force over ideal effort force. That look familiar to everybody from when we did the problems? Actual mechanical advantage, still the same thing. We have resistance force over effort force, and that takes into account friction and any other energy losses you'd have. Right. Inclined plane, flat surface at an angle with no moving parts. So you lift the load by pushing or pulling it up the ramp. Right. So the IMA for an inclined plane is the distance of the slope. So that up there. Oops, that's not what I wanted to do. So that up there, distance of the slope, not this part down here for anything. Does that make sense? And then that's divided by the height. So in this case, our IMA is going to be 15 feet for the slope, divided by 4 feet for the height, and that's going to come out to 3.75 for our mechanical advantage. That's the ideal mechanical advantage. AMA still works the same thing, or same way. So we have 20 pounds of effort force. The thing weighs 50 pounds. So it's going to be 50 divided by 20 for our AMA, so 2.5. And then efficiency is what over what? AMA over IMA. So it's going to be 2.5 divided by 3.75 times 100%, or 100 equals 67%. We need to have the pen on there. So a wedge functions as a moving inclined plane. Tapers to a thin edge, usually used for splitting something apart. So wedge, for the effort distance, we are going to use the length of the wedge. There is some argument among engineers about whether that's the correct way to do it. The other option is you have the length of the angle. So just that side, which would be a little longer to get the IMA. It's hard to do because it's hard to actually experimentally get the IMA of something. So there's debate as to which of those is right. We're going to use the length one. So it's going to be effort distance is going to be the length there we have, so distance from the top to the bottom, and the resistance distance is the top of that triangle right there. So IMA to the wedge to the right, if it goes in 10 centimeters, and this is not the height of the whole wedge, it's how far it goes in. Does that make sense? And then you're going to use the height at what point it went into. Which, does that make sense, everybody? So it'd be 10 divided by 3 inches, we'd get 3.33 for our mechanical advantage, our ideal mechanical advantage. Actual mechanical advantage, the one important thing here, it's resistance force, effort over effort force, or effort force would be 250, resistance force would be 700. It is not 1400. So a lot of people are tempted to add these together, the 700s together, but it's not 1400. So you just use whatever the force is on one side. So do 700 divided by 250, we get 2.8, and then AMA over IMA, we get 84% for our efficiency. Anybody have any questions on those? Screws are probably the trickiest mechanical advantages to calculate out of any of them. So the screw is kind of two components. The screw is really an inclined plane wrapped around a cylinder. So if you cut out a big triangle and wrap it around a pencil, you get something that looks like a screw. And so a screw is like an inclined plane that just goes around in a circle. So screws change rotary motion into linear motion, can be used as a threaded fastener. Screws have very large mechanical advantage. By far, they'll be the largest things we calculate. But they also have a large amount of friction loss. So the efficiency is usually really low, but the AMA and the IMA are much higher than other things we've talked about. Some information about screws here. So you usually see screw information like this right here. Why do I never have the pen on? So the first thing is the diameter of the screw. So that's the diameter of like the screwy part of the screw. Next thing is threads per inch, and then description if it's coarse or fine for like how the threads are. But the big thing you need to worry about is the threads per inch, because one of the things we're going to need to figure out is the pitch. So if there's 13 threads per inch, the pitch is the distance between the threads. So if we have 13 threads per inch, our pitch is 1/13 of an inch. Does that make sense? So the pitch is always 1 over the threads per inch number. And what that pitch means is that if you turn the screw around one time, it goes in as far as the pitch is. So if you turn this screw around one time with 13 threads per inch, it would go in 1/13 of an inch. Does that make sense to everybody? Calculate the IMA of a screw. We have to figure out the circumference of the circle we turn it in. So if you had like a wrench attached here, I'm going to draw an awesome wrench. So I'm just going to draw a line for the wrench. We're looking at it in profile. So we'd figure out the circumference of the circle that wrench made. The circumference of that circle would be the effort distance. So it would be 2 pi times the radius, so 2 pi times the length of the wrench. Does that make sense for the effort distance? And then the resistance distance is how far it goes in. So that's just going to, in one rotation, so that's just going to be the pitch. Does that make sense to everybody? So for our IMA here, if we had the screw above is an effort force by an 8-inch long wrench. So we're going to say 2 pi times 8 inches, since that's the radius of our circle. And then for the pitch of this one is 20, is the threads per inch. So our pitch is going to be 1 over 20. So it's 2 pi times 8 divided by 1 over 20. And we get our ideal mechanical advantage to be 1005, which is much bigger than the like 3s, 4s, and 5s we've been getting for everything else. The actual mechanical advantage works kind of the same way as it always has. The force you apply to that wrench, 35 pounds, divided by the force the screw goes in with, which is 1200. So our actual mechanical advantage is 34.29, which is still a big actual mechanical advantage, but is really small compared to the ideal mechanical advantage. So we end up with a really low efficiency when we take the IMA over the AMA over the IMA. And the efficiency is so low because screws tend to have a large amount of friction. So you lose a lot of your energy due to friction. Last slide. Compound machines. We'll spend a lot more time talking about this when we actually do compound machine problems. But the total mechanical advantage of compound machines is you find the mechanical advantage of each individual piece and multiply them all together to get the total. And these will kind of be the hard problems from this section in terms of like, I have some nice big ugly drawings of big compound machines with like 5 and 6 machines that you have to find the total mechanical advantage of. Alright, any questions? Alright,